our very next speaker, Andreas Kretz. You might already be familiar with him. He talks about all things data engineering and always about the plumbers of data science who really are really important into the entire data science process. So Andreas is going to talk to us today about data engineers, the plumbers of data science. He has over 14 years of experience with computer science, over 8 years of corporate data science and IoT experience, and has over 300 hours of data engineering coaching experience. He was selected as the LinkedIn top voice in data science and analytics in 2018 and in 2019. He holds a diploma in applied computer sciences and is also a YouTuber and host of the Plumbers of Data Science podcast. I'm going to go ahead and bring Andreas up on our virtual stage here. Hello, Andreas.
Hi.
Welcome to the show.
Thank you.
Thank you so much for being here. I'm going to go ahead and give you your 10 minutes, so I'm going to hop off and let you take it away, and then we'll be back with questions.
Awesome. Okay. Yeah, hi. Welcome, everybody. In this 10 minutes now, I'm going to talk, of course, about data engineering and what data engineers do and why it's the plumbing of data science. And we're going to talk a bit about why it's so difficult to learn, actually, and tools and platforms that data engineers actually work on. And I'm going to give you a few tips on how to get into data engineering. So generally, when you, as a setup, when you think about data engineering, where does that fit in? And it fits in, for instance, in data science platform. Every time you want to do some analytics and science, you need some kind of a platform where all of this is actually going to run on. And this is, or you have to think of this as like on the left side, you have your data sources where all the data is coming in. And on the right side, you have your consumers, your people that are going to work with this, data scientists, analysts, users in general that are going to view results. And so they need a platform. And this is where basically the data engineers are coming in the middle, and they're going to help build pipelines to support these users. For instance, for data scientists, what data engineers do is integration of the data sources that are on the left. So we actually bring the data in and make it available to the data scientists. So the data scientists can do their analytics work, can create really nice results. And then these results actually need to go to some consumer, a person, a system. And this is also where then more pipelines need to be built, where the engineer then comes in again and helps basically deliver this information to the destination. Data engineers also make sure that pipelines are actually secure, and the whole operations part, because just development is one part. Running pipelines, making sure they're actually running continuously, finding problems quickly through monitoring and all sorts of alarming functions, and then actually fixing these problems. That's all engineering. That's all the lower part. It's very important. This is why you see some companies like Facebook most likely had a bit of problems yesterday. Most likely this was an engineering problem. So the plumbing of data science, why is this the plumbing? It already alludes to, it's basically invisible. You don't see it. The end user doesn't see it. From the data perspective, the people who push the data in don't care. It's in the background. It's basically invisible. But if you do it wrong, if you have problems with this, it's a huge mess. Just like the actual plumbing from the plumber. So that's why I say it's the plumbing of data science. Now, that's all good. People find it, though, very difficult to actually get into to learn. And why do they find it? It's because it's there's very much to learn. It's a very wide field with a lot of tools and many platforms. On top of this is that every company, every use case has different needs, has different platforms. If you think of e-commerce, banking, or IoT, very different platforms, very different needs, very different tools in this. So when you look at this, and what I'm teaching to my students is there is actually a pattern behind it that you see all the time. And the pattern is basically this. Let me share my screen here. The pattern is basically this, that on the left side, how it starts is basically with an integration phase or integrate, where either you or the engineer hosts APIs, where external systems push the data in, or where you actually get data from external systems, like external hosted APIs or data warehouses that are already existing in the company, or some production relational databases. And then the data is actually streamed or processed in the middle, where very often you have in stream processing some kind of like a message queue, like Kafka is very popular right now. And then in the middle, you have your processing frameworks where you do the batch and stream processing, for instance, with Spark through a Databricks or something. And this is also where the scientists are going to apply their models or train their models. And then you're going up into a storage layer where you have your data lake, where you store your raw data, where you have transactional databases, where you have NoSQL databases, where you might have a data warehouse for internal analytics. And now on the right side here above me, this is where you have basically a visualization layer, where you have a web UI or a BI tool or a mobile app that uses actually a API that is hosted on the platform then to deliver these results from the stores. So this is very, I kept this very general because you can now, when you go in and look what tool does what, you can actually fill the tools in, and you always see this pattern is always works, and I have very good experience with my students around this. So look at the blueprint if you want that. You can check out my either my academy, where I talk later about this, or on my YouTube channel. I have actually, I think, videos on this that will help you towards this. One problem that I always get is, now with the blueprint and everything, it's nice, and you know how you can figure this out once you learn the basics. But people are telling me, okay, Andreas, I have this problem. I can't get a job because I don't have experience, and I don't have experience because I can't get a job. Like it's this cycle where people are stuck in. And there's actually a way of doing this for data engineering. It's a lot simpler than you actually think it is. You should get the basics done, and you need to focus only on two things there. Mainly software development. That's very important, that you can code with Python and work with Git, for instance, that you can actually collaborate with your colleagues. And then you can work with relational databases, not just SQL queries, but actually that you know how to design a relational database, because these are basically the basis of everything. And also when you work with NoSQL databases, whenever you know how to do it in a relational, you find out, or you can figure out how to do it in a NoSQL and what would be the benefits there. So once you have the basics down, what I recommend is doing a personal project. Personal projects are very important for you to actually gain some experience, not by working somewhere and or reading a book, but to actually have hands-on experience. Gain this experience using popular tools. Go out there, look on the internet. Most likely you can do something with what is very popular is Kafka, Spark, MongoDB, for instance, or build something on AWS. Very, very popular tools that you see all the time. You can also use real world data that you find, for instance, on Kaggle, or use an API that is public, where you can then actually say, okay, let's see, I want to work in e-commerce. Let's see what in the job descriptions, what are people using in these industries, and like which tools, which platforms, and then find yourself a data set and work with this. And once you document this then and show your progress, then you can show actually to somebody in an interview. I couldn't talk about this in an interview, and actually show some experience, although you don't have like experience working in a job. So for somebody who's actually starting out, coming from university, or want to transition to data engineering, this is actually the perfect recipe. How I'm usually helping around this is, I mentioned it before, I have actually a data engineering academy where I'm using actually this personal project topic. In the academy, I'm teaching the basics of data engineering. I have prepared projects for AWS, for MongoDB and so on, or that use MongoDB, and Spark and Kafka, where you can actually say, okay, I'm taking these projects, I'm documenting these, and I'm doing it step by step, and then I'm expanding these, and you're going to find topics that you find interesting and you want to look into, and then you can add stuff up and make this project your own. These are all prepared stuff. I also do, as Kate alluded, I do personal coaching. Now for 2 years I've done this as a part-time thing. For some time now I'm doing this full-time. I'm coaching students one-on-one to actually get or become a data engineer or learn data engineering if they're a data scientist. Yeah, if you want to learn data engineering, check out my academy at learndataengineering.com. And if you just want to check out my YouTube, I'm posting all the time on YouTube. Find me, Andreas Kretz, on YouTube. I think I have 350 videos right now about data engineering. Right now I'm focusing a lot on actually making videos where I review architectures, for instance, on AWS from companies. It's really cool. It's a lot of fun for me. People like it. So check it out. And that's already it. Thanks.
Awesome. All right. Thank you so much, Andreas. Amazing presentation. I really love how you get creative with the slide behind you. I've yet to master how to actually do that. You go from being in the sky with having this cool pipeline behind you. We have a lot of questions that came in, which is really cool. People really care about data engineering. I'm going to go ahead and ask one of the questions here now from Diego. The question is it necessary to use Kafka to store data, or can another technology be used?
Yeah, well, you have to always look into what you want to do with the data. Kafka is more as a message queue where you push data in and you publish data to it and you consume it. So it's usually not meant for long-term storage. These things are more for, I'm keeping it for a day or 2 days or a few days. There are, of course, exceptions to the rule. As I said, there are a lot of tools and there are extensions where you can actually use it as a database. But these things are mainly meant for streaming data, for keeping this temporarily.
Okay, awesome. Thank you.
Cool question, Diego. Thanks.
All right, the next one from Mahendra hopefully doesn't hit a nerve for you, Andreas, but what are the roles that data engineers perform? So what are some of the technologies? I know you covered some of this already. So what are the technologies that a data engineer needs to learn? Is data engineering just a new buzzword for roles, tasks done earlier by some other title? Or do you think data engineer is this kind of new standalone role?
Yeah, let me start with the last. Can you leave it up, because it was basically a three-part question.
Sure.
The last part, of course, it's not a completely new job, right? It's where do you find a completely new job nowadays? But it's a combination of a lot of things. And nowadays, whenever when you build new platforms, when you work with data scientists and data science, let's say data science pipelines, you need a job that is more integrated, that does everything end to end. Previously, you had a lot of jobs you had your database administrators who were focusing on the database. You had your networking people who did the networking. And now, nowadays, you're more focusing on doing an integrated job. And that's where the data engineer comes in. And basically, that also answers the first question. Best case, you do everything. You from getting the data in to actually making it available at the end.
Right.
Depends a bit on the use case and if it's a startup or like just an analytics platform. But I think that goes too much into the details. Technologies, it's hard to say. Look into job descriptions. There's everything, but most of the time you find something like AWS, because people move to the cloud and AWS is the most used one. and then the tools within AWS that fit actually to the blueprint. Yeah.
All right, thanks for that. There's a question from Goran just asking if there's a replay for the sessions. Yes, the recordings will be up on LinkedIn and YouTube. We'll actually have a playlist as early as tomorrow. And Andreas, several other questions, data engineering related, that if you have the time to hop over to LinkedIn and respond individually, that would be great. But I think we are at time here for our session. So thank you so much for your presentation.